Okay, here's a video on the properties of parabolas and finding the equation of a parabola given 3 points. So basically with this first one here, they're giving us an x equals equation, so we're kind of anticipating, or you should be anticipating, a parabola that's going to open left and right because it's x equals. And then it's in vertex form, so there's always an a value. Y always gets paired up with k, and x was with h, and I always remembered x for horizontal. So if it's y on the inside, that means it's going to be a k with the y. And then you do just need to remember as well, anything inside the parentheses always has an inverse effect, so it's actually an opposite effect. So what I mean by that, the vertex of this is actually going to be the x-coordinate is the one on the outside again, and the y-coordinate is the opposite of the one with the y, so -2. So we're sitting at 1, -2 for the vertex. Then we need the focus, and we need the directrix, and we need to just sketch the graph. So to figure out where this other stuff is, the focus and directrix, we need to find the focal length, again, which is used with the variable p, and there's a formula that says p is always 1 over 4a, and the a value in this one is 1/4. Okay, so make sure we're doing the multiplication first, right? Do 4 times 1/4 first, and you end up getting 1 over 1. So the p-value actually just equals 1 here, and that's going to tell you the distance from the vertex to the focus. So for this specific problem, if the vertex is here and the parabola opens to the right, that means that the focus is going to have to be 1 unit inside. It's always inside the parabola. So the focal point will be right there, which is at a x value of 2 and a y value of -2. And again, the distance between the two, from here to here, that p-value is a distance of 1. Okay, and then on the other side is where the directrix will go. The directrix will be 1 unit out this way, so it's going to be 1 unit away, and the directrix is always a line, so in this case it's a vertical line because the parabola opens sideways. And the equation of that vertical line is just going to be x equals 0. Okay, it's basically the y-axis. And then the parabola itself, again, just kind of a sketch. You'd have to plot some points to get more accurate, but just show it opening to the right, and that should be good. Okay, moving along, numbers 2 and 3, they're giving us some other pieces of information, and we need to find the equation. So the grid there we can just use to help us label some points and whatnot. So 6, 5. So I know the what is that? The focus is there. Okay, and then the directrix is at y equals -1. So y equals -1 is going to look like that. Okay, so we know the vertex is always going to be the same distance, right? That's the whole definition of a parabola, is that it's the set of all points equidistant to that focal point and that directrix. So the vertex will be right in the middle. So we have 1, 2, 3, 4, 5, 6, 1. So I think right about there should be our vertex. Okay, because that's 3 units away from the focus, and then it's also 3 units away from the directrix. So it looks like our vertex is going to be at 6, 2. Okay, so that's going to end up being our h and k. And we can also see the value of p. So that distance from there to there is what we call p. And in this case, it's 3. So p equals 3. And that means that the a value, which actually goes in the equation, will be 1 over 4 times 3, or 1 over 12. Okay, so now we just need to plug this stuff in. We have the vertex and we have the a value. The graph's going to open upward because of the where the focus is, or if the focus is above, then the graph opens up because the focus always ends up inside the parabola. So we know it's a y equals equation. It's going to have a positive a value. Since it's a y equals equation, it'll be x minus h, right? H always goes with x, and then k on the outside. So plugging in our specific values for this one should get us y equals, we just found a as 1/12. Okay, x minus, so the x coordinate of the vertex is 6, and the y coordinate of the vertex is 2. Okay, and again, it's x minus 6 because it's always the opposite for the whichever factor, or whichever term is inside the squared the squared term there. Okay, next one they're giving us now is a, let's say they give us a vertex and a focus. Okay, so let's mark those on there. The vertex is -2, 4, and then the focus is -3/2, 4, okay? And -3/2 is -1.5, if you like decimals, just to kind of get an idea of where it might be. So that means that point is going to be -1 and 1/2, 4, so it's going to be over here. Okay, it's half a unit away. Okay, the difference from there to there is a half a unit, so P is 1/2. Okay, and I know again that this thing's going to open up where the focus will be inside. Okay, so it's going to open to the right. So I'm expecting an x equals equation. Okay, so that means it'll be y minus k squared plus h on the outside. Okay, and we know the vertex, so we know h and k. Okay, and we do just need to find a. Okay, so again, there's a and p are always related to each other. So if we know we knew p, a is always 1/4 times p. Okay, so 4 times 1/2 is 2. So the a value here will be 1/2. And it is positive because this graph is opening to the right because the focus was to the right of the vertex. So it's going to be positive 1/2. Y, the y coordinate of the vertex is 4, so -4. And the x coordinate is -2, so it's the actual value. It's not the opposite for the one on the outside. Okay, so we're looking at x equals y minus 4 squared minus 2. Okay, and then moving to the back here, we have, okay, so here we're given 3 points. We need to come up with the equation of a parabola. So we can try and get the coordinates of these points here. That first one there, it looks like -5, -3. Okay, so what we're going to do is we're going to write an equation in standard form. So y equals ax squared plus bx plus c. And we're going to end up getting an equation for each of the 3 points. Okay, so just kind of follow the format. So y, so -3 equals a times the x value, which is -5 squared, plus b times the x value, which is -5, plus c. And then we'll just kind of simplify a little bit. -3 equals, so -5 squared is positive 25, so positive 25a, minus 5b, and plus 1c. Okay, so there's an equation right there. Okay, and then doing the same thing with another point. If we use the point -4, 0, so that one would look like the y value is 0, a times the x squared plus b times the x plus c, so 0 equals 16a minus 4b plus 1c. And then finally, using the point 0, -8, we would get -8 equals a times 0 squared plus b times 0 plus c. Okay, or -8 equals 0a plus 0b plus 1c. Okay, and I'm now going to take the 3 equations and we're going to solve a system to figure out what the a, the b, and the c are. Okay, and to do that, we're going to end up using the matrix method. Okay, because it is a 3x3 system, so we don't really. I mean, if you want to do elimination or substitution, you can, but matrix is going to be the way to go. And the setup on that's going to look more like you're going to have the coefficient matrix, so the 25, -5, 1. Second equation, the coefficients on a, b, and c were 16, -4, 1, and then 0, 0, 1. Okay, and that's going to go in your calculator as matrix A. Okay, it's going to get multiplied. We're not going to do anything on the calculator with ABC yet, but we're going to, that's what we're going to solve for. But then it will equal the coefficient, or the constants, I'm sorry, 3, 0, and negative 8. Okay, and that's going to go into your calculator as matrix B. And this one we just call X because it's the variable. And the way to solve for the one we want, the one to solve for the variables right here, okay, since it's A times X equals B, we would try and get X by itself. We can't divide with matrices, so what we're going to do instead is if you have this kind of setup and you want to get X, what you can do is multiply both sides by the inverse of matrix A. So X, the matrix with the variables in it, will be the inverse of A times B. Okay, so I noticed a typo. I had missed a negative sign on the 3 up here, so make sure we get that in there. That came from the constant in the first equation. And then multiplying the matrices on the calculator, I ended up with the variable matrix of -1, -6, -8. So what that means for us is our equation in standard form is going to use those 3 values. So this answer right here to find the equation is going to be y equals -1x squared minus 6x minus 8. Okay, again, here were the a, b, and c values for it. And in the axis of symmetry, you would have to, there's a couple options. You can either graph the equation and find the maximum, and you'll know where the vertex is, and then you could just write an equation. So I'm just typing this in the calculator real quick. I put the equation in. I'm going to go to find the maximum real quick, okay, and find that the maximum occurs at -3, 1, okay. So the graph again has a, just something like this, and the vertex, sorry, I didn't draw that very good, but just pretend like the vertex was there. It was -3, 1. Okay, so that means the axis of symmetry, we kind of go right through there, and the equation of that is it's going to be x equals -3. Okay, now there is actually a way to do algebraically. There's a little formula that we may or may not have covered yet in class, but x equals -b over 2a is a way to find the x coordinate of the vertex. So once we got the equation, okay, we can do negative, so the opposite of the b value. So b is -6, so opposite of that is +6 over 2 times the a value, and you'll end up getting 6 over -2, which actually gets you that same x value that we got for the axis of symmetry. Okay, so that's a little shortcut. And if you notice, that's actually kind of part of the quadratic formula. That, the rest of it has the plus or minus square root of all that stuff in there. But yeah, that's just an algebraic way of getting the axis of symmetry without needing to actually graph the equation. Okay, but either way should work. And those are your answers, and that is how you do it.